Hello everyone, welcome to the second day of Dev Days Europe 2023. We're in the first half of our session today and we have Trista with us, a very impressive tech lady. She's co-founder and CTO of SphereX. She's an Apache member and incubator mentor. She has multiple awards: 2020 China Open Source Pioneer, 2020 first Oscar for Top Open Source Pioneer, CSDNS 2021 IT Leading Personality, and recently Chief Technology Officer of the Year by Globee Awards. There are more to tell, but today she will help us unravel how to achieve elastic and secure OLTP cloud computing for our databases. Trista, it's you now.
Yeah, thanks. All right, hello everyone. This is Trista. I'm so happy today to give this talk. Let's start from the first slide. Yes. So I'm so happy today to share this topic around our big data, especially around the databases, because my area, it's around the databases, around the open source. So today our topic it's about how to leverage our existing very wonderful open source, for example, the PostgreSQL or MySQL as well, to create the distributed database cluster, especially on the cloud or on the Kubernetes. Yeah, so that's the key point of today. I'm Trista, and now I'm the SphereX co-founder and CTO. So my area is around the cloud, around the databases. So sometimes I will post some articles or tech articles or open source articles on my Twitter or LinkedIn. If you're interested in such topics, or today you already have some questions, we can talk more on my LinkedIn or Twitter. Yeah, so why I want to share this topic, because I guess you know that everyone now is talking about the SaaS or the PaaS or the apps and about the databases. So because we really want to leverage such service to help us to deal with the issue around the big data, around your databases. Today, we will talk about all of the item. First, I will give some the brief introduction about the SaaS or the apps or stuff, and then I will give some definition around what that's OLTP computing and traffic governance, and then let us consider about the issues now we face, especially in the big data era. And then I will give the architecture idea and the solution. The last part, it's about why do it by ourselves. I really did a demo show, and if we have some time, we can give you a look there. Therefore, you can not just know that what's the idea or the architecture of this talk. You can also, really dive into it to experience or practice it, right? Yeah, so that's all about today's content. The first part about the anything as a service. It's a service, that when we have the cloud account, you can see a lot of the different product or the service on the provided by the third party vendor or cloud vendor, and they want you to set it up quickly, and you can scale in or scale out automatically based on your business scenarios. And if you meet some or encounter some issues, you want to get the professional help or support, or you will consider your cost for your infrastructure. So that means we adopt this pay as you go, this approach way, and to get the benefits from this idea. Because of that, that's why we're always talking about the SaaS, IaaS, or PaaS, because it really can help us to get the following benefits from all of the different services. Like you go to the market and you want to buy something, you can just click the button, and you set it up and have a try. So that means it's so efficient for us to create our infrastructure. So that's why it's so popular. So today, I also want to present a solution that can bring us such the properties. I mean, efficient or easy to set up, or I mean, everything is out of the box of the deployment, and you can get some help from the open source community or the maintainers. Yeah. So, I mean, my solution is share the similar properties of pay as you go this model. Yeah, so the next part we will consider about the database and the tech part, because I guess most of people are using PostgreSQL or MySQL or other database. They're so good. I don't want to talk about big topic, because when we consider the big data or the SaaS ice and all the stuff, that's will, I mean, too big. Today, I just want to focus on the databases, especially distributed database system. And you know that uh, before, I mean, 10 years or 5 years ago, people found the PostgreSQL or MySQL were so good. They're enough for our scenarios, for our requirements to help us manage data or use data. But gradually, I guess most people found that because we enter into the big data era, and we found that there are tremendous data to manage, especially sometimes there are so different types of data. Your document, your JSON, or your key value, right? Or your cache. And apart from the types, you also found that now we have the enormous data in the to manage. That means maybe 10 years, one or two or a cluster where Postgres is so good, is enough. But now, or if we needed to consider about the 10 years later, we'll consider that maybe at this time we need to consider how to upgrade our existing database infrastructure. That's why you can see a lot of database vendor or cloud vendor, they are created or develop their own distributed database. For example, the QuadroDB or Aurora or Cosmos DB, right? So there are so many different databases for us. Why they come out? Because we need it. Because this time needs such the new product to help us to manage data, to store data, and to use data. Yeah. So people now consider how to upgrade my database and infrastructure to be the modern one. It's like I said here, it's a big change, because I mean, nobody wants to overturn their database infrastructure or other infrastructure, because all of them are fundamental factors or atoms for our companies or enterprises, right? So we will consider that how do we upgrade our database infrastructure into a modern one or distributed one, and with the lowest cost, right? So you consider about that, because you will worry about that maybe currently one single monolith databases, they can work so well. But how about 5 years? How about 10 years? How about our company become larger, our data become the PB or TB to manage? So that's why, I mean, maybe now it's the right time for us to consider to upgrade our infrastructure. Today, it's about the database infrastructure. So you may consider at how to manage the large data, and because the data has different types, and there are so much, And even though you also your application or your service for your end user, you also want to have the high throughput and make each querying as fast as possible. And the better one that it can skew out skewing based on your current scenarios. If they can do all the stuff automatically, that would be perfect, right? And the next one that the solution can provide some out of the box of deployment or setup can help me to easily manage it or use it or to do the upgrading stuff. So I know all of the benefits you want to get from the current the solutions or new databases because I really experienced such an upgrading stuff because in my previous company we use a lot of the Oracle instance database instance, but now we use a lot of other new SQL databases for our company. Yeah, for my previous company, because now we create work staff company and to do such professional stuff. Yeah, so okay, so I mean there are actually a lot of solution for you to choose. For example, you can just pick up the favorite cloud vendor and clean it up, and you can the cloud vendor will help you create the corresponding database instance, right? Or MongoDB or the Aurora database. Yes. Another one, like I cited in this slides, that there are so many wonderful distributed database or no SQL database vendor. They present you a lot of good database product for you to choose, and they also provide their SaaS for you to set it up. Yeah, that's fine. That's okay. And I also, because I always I'm in this area, I really give a lot of time and to look at their product and try their product. I think, yeah, they really did a good job. But sometimes maybe you consider that uh, if there another solution, they can meet all the following requirements and also can help you to not overturn your existing MySQL, PostgreSQL infrastructure, but to leverage the existing MySQL, PostgreSQL, or Oracle SQL Server databases and just to use them lowest cost to upgrade it to become a distributed database. And I mean, that means you don't need to overturn your database infrastructure. You just consider leverage the existing environment, the existing architecture, just add some or import some projects to upgrade it to become a modern one. And because that means you don't need to consider totally, I mean, migration, the data migration from your existing monolithic databases to another, I mean, the totally new the databases, right? And also you don't want to be, I mean, sometimes you consider you need to do the balance between different the cloud vendor, right? Because you know that different cloud vendor they give you different I mean discount, but sometimes will not. And if one day you put all of your infrastructure just in one cloud, that means in the future you have no choice. Because if you really want to move to another cloud, that you need to pay a lot of time, effort, your stability, all the stuff. So think twice. You don't want to be locked in one vendor, right? So that's why I later on I want to share another solution for you to consider. I mean, because there's no perfect solution. Each one have its trade-off, the pros and cons. I just share one solution for you, and if you can think that, oh, maybe it's the best one for my case, yeah, I think that will be helpful. But you think, oh, maybe it's not the good one for my case, and you can just consider other solutions. I mean, there are so many wonderful products. They really did a good job, and you can just have a try. All right. So, what's that solution? Before I introduce the solution, I want to introduce a little bit about the technique, because from the tech perspective, if we want to make our final solution or final project or final product to reach the following, I mean, the levels or the requirements, there needs some the technique to support such requirements. So what all of the techniques, for example, the first one, if you want to make the single monolithic databases into the distributed one, then you need to do the data sharding. That means you need to split one single database or one table into a lot of small ones, or the shards, and put the different shards, independent shards or small parts, into different machines or servers. So your single monolithic, the database will become a distributed one. So that means your data is sharded, and will be stored in different location, right? So that's the first one. The second one, if we want to reach the high throughput, that means, we need to guarantee we want to have the high availability. That means our databases, it shouldn't be the single one instance. We need to create a lot of replica for the primary database or instance. So we can use the replica to guarantee the availability. For example, if your primary nodes crashed down, and your replica can become the primary instance to provide the service. Or we can do some the traffic governance. For example, because there are so many replicas online, so if we found that this querying is for get some of the data from our database, we can just send such queries to the replica, and the replica can provide the part of the queries. But if we found that this querying that people want to do some modification to our data, then we need to, route such queries to our primary one. Yeah. So that means we do the load balance between or among the different primary nodes and your replica nodes, right? I know that's all the basic architecture for databases, but if we can have we can have the data proxy, if we can have a server can help us do such stuff automatically, that means we don't need to care too much about the internal handling stuff. Such product or such project can automatically help do the data sharding or rewrite splitting, or they can help us to pick up the primary nodes or replica nodes. And also, it can help do other wonderful features. We just ask such server or such database or such project, hey, could you help me automatically do the data sharding, or help me to guarantee the high availability? That's all. Because for a developer, I don't really want to care too much about all the stuff. I'm a user. I just want everything to happen by itself, right? So that's why, even though maybe most of you know such the basic stuff, but today I want to introduce the project that can help us do it by itself. There's no need for us to manage the connections, manage the the URL to connect to your database, or to watch or monitor your status, the status of your databases. We don't want to do too much about that stuff. We just want a service. That means everything, it's a service. I hope some project can provide a service for me to leverage such techniques. Yeah. So next part, I will introduce this open source project. But before that, we need to understand why does this project can help us do such stuff. Because if you just give a look at other database architecture, for example, MongoDB or QuackDB or other database, you found that most of such databases, they share the similar architecture. The architecture, it's made of at least two important parts. The first one is computing nodes here. The second one is storage nodes. Sometimes they will have the governance center, or like the management center to help them to do some the manage the global metadata, or do some run some the background jobs to collect some the metadata from the whole distributed database cluster. But at least such distributed system, they will have two important elements. The first one is computing nodes. Computing nodes will work at the entrance, or the server, right, or the router, or the proxy. It will receive the queries, or deal with the queries from your application, or from your end users. So it will work like the global computing node, do a lot of computing, handle the queries from your endpoint. And storage node, like its name said, the major function of such nodes is to help us persist our data. And it will also do some local computing the stuff or work. Therefore, it will serve as the local computing node and storage node. Therefore, your computing node will just do some global computing, and to found that maybe this time we just need two storage nodes to do the local computing, and to give or present their local roles or the data to me. And at the global computing node, I will connect to different storage nodes and get the local readout, and merge the local readout, become the final one, and send the final result to the requester, or to the application. So based on this idea, that means we can find some replicants to fill in this architecture. We have found some projects to work as the computing node. We have found some projects to work as the storage node. So here you can see your existing PostgreSQL, because they are databases, as the single database, they work so well. But now we will consider, could we make it become the distributed one, right? So here, a single or a monolithic PostgreSQL instance will become one of the storage nodes in this distributed database system. So like this illustrating shows that one of the Postgres will work as the storage nodes, and they will help us do the local computing and help us to persist the part of the data, right, in this Postgres instance. And different Postgres instance, they will work as the independent, local storage node. And we can just found another project or the proxy works as the global computing nodes. Therefore, all of the computing nodes plus or existing MySQL or PostgreSQL will merge them or group them into the final distributed database. So that's what I want to explain in that we don't need to totally, shut down or existing MySQL database or Postgres database. It can work well, even though in nowadays. And we just to find some computing nodes and to make this computing needs to help us to manage each of the Postgres instance. And also, plus all of the computing nodes, here, it can help us to make the existing independent Postgres instance become logic single one distributed database. So who can be that role? This project, Apache Sharing Sophia. Sharing Sophia, it's the Apache top-level open source project. And this project, you can see its slogan, its function is to transfer databases into a distributed one. Actually, this project, it's a big project because you can see this slides that it has been open sourced for over 6 years and has a lot of contributors and already released for nearly 15 times and have the mature documents for us to set it up quickly. Yeah, so from the statistics on GitHub, we can consider this project because it's not a brand new and it can be existing for over 6 years. That means it's helpful and valuable for this world, right? If not, there's meaningless to exist so long, right? Yeah. So the next part, this project actually have two clients for us to choose. First one, like I said before, Sharing Sophia proxy, one of its clients can work as the global computing node and can when we use the Sharing Sophia proxy, it can help us to manage all the four PostgreSQL databases or MySQL databases. But for our application, we can just create the connection to this single entrance. This single entrance is Sharing Sophia proxy. And that means your application just think, oh, I have a distributed database system here, and I can just send my query to the Sharing Sophia proxy, and this proxy can help us to manage the data, can help us to do the data sharing, can help us to do the rewrite splitting, and also can help us do the following features. For example, the data encryption. Like GDPR, you know that we cannot put the plain text of the sensitive information in database. We need to encrypt all the data, right, and store the encrypted data in database. So because you can see here, your application just talk to proxy, and Sharing Sophia proxy will create a connection to different your Postgres instance or Postgres clusters. That means all of the queries will first reach Sharing Sophia proxy. So, and Sharing Sophia, it's a good DBA or it's a good manager. He can know that what's the meaning of your each querying or each request. And because he will do the SQL parsing, and optimize your SQL querying, and also to do rewriting your SQL. And this proxy, he knows that this time, the data, the location of your each PostgreSQL database, right? That means each of the shards, the data shards. So that means this proxy has a lot of power to, rewrite your query. For example, here I can give you example here. For example, if for your application, you just think that the proxy, it's a distributed database or distributed PostgreSQL database, and the application just send his request to proxy. For example, the application will think that this distributed database has this table named user, your count table, right? This count table actually, it's just a concept or the logic table name in proxy. Actually, this logic table, it's made of 4 shards located in 2 PostgreSQL cluster. So you can see here the user 0 and the user 2 subtables now are locating in the first, the PostgreSQL cluster, because you can see here in this database cluster, PostgreSQL cluster, there it's only one primary nodes and a replica nodes. So, and you know that replica, it's the replica of your primary nodes. So we will consider that this table user, it's made of 4 shards or 4 actual tables or 4 subtables. 2 of them locate in the first cluster, and the remaining 2 are located in the second cluster. But for your application or for our users, we don't need to care too much the details about all the stuff, because the proxy, it will help you do the data sharing automatically. And plus, as I explained in previous slides, that because Sharding Sophia or Sharding Sophia proxy, it understands each queries. So it can leverage the replica. That means this time, for example, you just want to get some data from this distributed database system, and proxy will automatically route this select everything from table, this query, to the replica one or to the primary one. There is a load balance strategy for you to choose. You can just send all the read or write traffic to single one master or primary nodes, or you can leveraging all of the instance. Part of the queries will be routed to the replica one, part of them will be routed to the primary one. So all of that happen internally. You don't care about the details. So you can see here, because it's really like the load balancer or database gateway, because it can just help you to manage your database, your data sharing, read-write sleeping, traffic, and plus, about the SQL firewall or audits. If you see the SQL Server, they have some the wonderful security database features. For example, they can help you do the data audit. That means maybe some bad guys, they did bad things to these databases, and the proxy, it found that, oh, this time there's some the harmful queries come, but my administrator told me that, hey, you cannot allow such queries. For example, drop your table, truncate your table. They're not allowed it to do, right? Therefore, the proxy will block such the actions, and also log all of the bad actions into the logging. Therefore, next time you can see who, when, who, what action and happened. Yeah. So that means this good proxy can help us do a lot of work. Data sharding, SQL audit, SQL logging, SQL firewall, or data sharding, data encryption. Oh, I forgot about that feature. Data encryption. Data encryption is another great feature because all of your query will first reach at the proxy, and proxy know that because you can tell the proxy, hey proxy, this time I want to save the user's number into my databases, but I cannot just let my database store the plain text of my telephone number. So could you help me to automatically encrypt the data and put them into my database, right? And when I want to get all of the number, please help me automatically decrypt all of the data and tell me the plain text. So all of the stuff will happen in the Sharding Sophia proxy. Sharding Sophia will help us do the data encryption, decryption, or data firewall, data logging, SQL logging, all the stuff. So that's all the functions that this Sharding Sophia proxy can help us do. So that's I introduced the function and what issues it can help us do. Come back to this page, that because Sharding Sophia, it has two clients for us to choose. First one is proxy. It's easy to use it, right? You can just independently deploy it in one single machine or virtual machine, and it will work as the server, database server. And another client for us to consider, it's the Sharding Sophia JDBC. It's actually for the Java application. You know that JDBC, right? If you're a Java developer, if not, maybe you can understand my meaning. Yeah, JDBC, that if you want to connect to your database, you need an interface for the Oracle or the SQL Server, MySQL, right? So here you use the same JDBC interface, but you will use the Sharding Sophia JDBC because Sharding Sophia implement most of the JDBC interface. And it's why does it implement the JDBC interface? Because it's want to help us do all of the enhanced features I mentioned before. If you just use the standard normal JDBC, it can just help you create the connection to your database, but it cannot help you do such following things. But if you use this one, it can help you do all of the stuffs here. Yeah. So for the Java application, I mean, that is so easy. You can just use the Maven and use it. Yeah. So, but for the Golang or Rust or Python, I mean, I recommend the Sharding Sophia proxy. You don't need to write some the Java coding stuff. And next part, I want to introduce another idea about how to solve the issue that your application now it's living in Kubernetes, but your databases maybe not. Because people have the concern that it's really okay that to put my databases on the Kubernetes cluster. And here I can give another solution for you to consider. This solution, I mean, the idea is same because we can split our distributed database into two parts. The first one, computing layer, the second one, storage layer. So we can just put part of our distributed database on the Kubernetes cluster. How to understand that? Because here, if we just see here your PostgreSQL, it works at the storage nodes, and your sharding Sophia proxy, it works at the computing nodes, and both of them will become the final distributed database, right? So we can just put this proxy, sharding Sophia proxy, into your Kubernetes cluster. That means because the proxy, it's the stateless application, so it's born. I mean, for the Kubernetes, or Kubernetes just born for the stateless application. So it's for sharding Sophia, it's very easy to leverage the Kubernetes capabilities and to live in Kubernetes. Your application just to use the endpoint to connect to the proxy, and you don't care about where's your database. Your database can be in the Kubernetes cluster. That's here, your PostgreSQL, you deploy PostgreSQL in database pod, right? Or it can be the RDS service. I know that some of you guys will use the RDS, right? So you don't care about your RDS, it's the Google RDS or AWS RDS, right? Because it's just a service. You can just make your application talk with the computing nodes. Here, the sharding Sophia proxy located in the Kubernetes cluster, and let the proxy visit your RDS or your databases on premise anywhere. Yeah. So that gives another solution or another way to it looks like that put our databases into Kubernetes cluster. So that's another method for you to consider, because I know that currently a lot of the database vendor, they are consider how to really use the storage class or the PVC to put their databases, especially the persistent part, the storage part, into the Kubernetes cluster, right? That's okay. I'm looking forward its development. I don't know in the future what will happen for such a stateful application. I mean, living in the Kubernetes. But today, I just give another approach for you to consider. Maybe you can just leverage your existing RDS service and deploy sharding Sophia and proxy and make them living in the Kubernetes, and also upgrade your existing RDS become the single distributed databases, and you can skew in or skew out based on your current status. Okay, we have no more time. And the next part, I need to introduce the language distributed SQL, because you know that if it's a MongoDB, you will use the MongoDB's API to visit their database. If you use another databases, you need to use a specific language to talk with such databases. But here, if we want the sharding Sophia, this proxy or this new databases to help us do the data sharding or read-write splitting or SQL audit, SQL logging, such an advanced feature, then we need another language. That means the sharding Sophia SQL. That means the distributed SQL. The distributed SQL will it looks like similar with your standards and SQL. You can see here, if we just want to create our table, we can write create table T order. But here, if we want to tell the sharding Sophia, hey, You cannot just create a single table for me. I hope you create a sharding table for me. Therefore, you can just use a distributed SQL to write that part. You can see this language, that's the grammar. Create a sharding table for me. And the following is the definition for this sharding table. Then when he receives this SQL, he will definitely help you create a sharding table for you. Yeah, but that's all right. Just 1 minute. You can see here. For the out of the box solution, you can just visit this page because it provides you the operator and the helm for you to one command to deploy the cluster, sharding deploy cluster in the Kubernetes. So I want to introduce more about it maybe next time, because we have no enough time. And about the demo show, maybe later on you can refer to this in PDF and do it by yourself. All right, that's all about today. Thanks.
Thank you so much, Trista. I think many of us will recognize this new approach, new solution, if they're not familiar with it yet. 30 seconds for one very quick question. What are the symptoms that a company needs to move to a sharding database?
For example, the first one, some of the companies, they are now leveraging a lot of the PostgreSQL or MySQL cluster, and they don't want to do too much to infrastructure, but want to solve the performance issue or want to help them, the new solution, help them to manage more data. They can consider this solution. Or some of the companies, they are worried about that if I just only use one vendor, maybe I will be locked in. So I want to use a different the database vendor or the cloud solution. Therefore, you can consider put a part of the database in one vendor and put another part in another vendor. Then just using the open source project to help you manage the different databases located in different clouds. Yes.
Thank you for the answer. Thank you for the presentation, and see you everyone after the break.
All right. See you. Bye.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I